So let us look at the next problem. Negative feedback in a closed loop control system does not. So tell me the answer for this. Option A, reduce the overall gain, reduce bandwidth. Option C, improve disturbance rejection. And option D, reduce sensitivity to parameter variation. So you see some new terms here, right? So sensitivity to parameter variation. So you must be knowing what is sensitivity first of all, right? So take down the heading sensitivity, right? So sensitivity is represented with this symbol S of M with respect to G, right? Sensitivity of overall transfer function M with respect to G. This is the symbol we use to represent sensitivity, right? So sensitivity of overall transfer function, with respect to G is equal to. So I'll tell you, there is a formula we'll get for this sensitivity. Yes, see here, sensitivity is defined as the per unit change in M with respect to per unit change in G, right? So sensitivity is defined as the unit change in M with respect to unit change in G. Change in M, right? So change in M is expressed as differential of M, partial derivative of M actually, right? So dou M upon M, this is change in M, per unit change in M, right? Per unit change in M divided by per unit change in G multiplied by 100. If you want the sensitivity in percentage sensitivity, then it is per unit change in M divided by per unit change in G, right? That is equal to what? If you just simplify this, you will get dou M by dou G multiplied by G by M. Dou M by dou G multiplied by G by M multiplied by 100, right? Many of you would pronounce this dou as del. This is not del. Del is different, dou is different, right? Dou is different. Dou is used for partial derivative, whereas del is different. Del is this. This is del, right? This is delta. Clear? So be clear with the symbols which you are using, right? Therefore, sensitivity of overall transfer function with respect to G. See, sensitivity of overall transfer function with respect to G is defined as per unit change in M with respect to per unit change in G, right? Per unit change in M upon per unit change in G. That is the definition, right? So what does it physically interfere? What does it physically infer, right? M is what? M is overall transfer function. G is forward path transfer function, right? Overall transfer function, and G is forward path transfer function, right? So you have G in any general closed loop feedback system. What is G here? G is the forward path transfer function and M is the overall transfer function. M is equal to G by 1 plus GH. G of S upon 1 plus G of S H of S, right? M is overall gain. G is just the forward path transfer function, right? So sensitivity is defined as what? It is defined as the partial derivative of M with respect to G multiplied by G by M multiplied by 100, right? So what does it physically infer? What does it physically infer? Let us say, tell me, or answer to my question, that you have bought a ceiling fan, or else let us say you have bought an AC, right? So today the AC, if you turn on the AC and set the temperature at 22 degrees centigrade, let us say you have turned on the AC and you have set the temperature at 22 degrees centigrade, right? So the AC is taking, the air conditioner is taking 10 minutes to achieve 22 degrees centigrade from standard temperature and pressure conditions, right? in standard temperature and pressure conditions, let us say your air conditioner is obtaining 22 degrees centigrade in 10 minutes, right? So after 1 year, or else let us say after 10 years, after 10 years, will your AC bring the room temperature to 22 degrees centigrade in 10 minutes itself? Is it possible after 10 years? See, what is sensitivity is, the definition for mathematical definition for sensitivity is nothing but the ratio of per unit change in overall transfer function with respect to per unit change in G. That is it, right? Per unit change in overall transfer function to the per unit change in G. This ratio is called as your sensitivity of overall transfer function with respect to feed forward transfer function G, right? So dou m by dou G multiplied by G by m into 100. This will be used as a formula, right? So m is the overall transfer function and G is forward path transfer function. So many of you have given the right answer, right? That if we are using an AC, right? So initially, right, if it is brand new AC, right, it will give 22 degrees centigrade temperature to the room in 10 minutes. Whereas if the AC has become 10 years old, it may take around 40 minutes to reach 22 degrees centigrade, or else it may never reach at all, right? कई बार होते हैं ना ऐसे खराब AC, right? So it may never reach at all, right? So this is because of aging of electronic components and electrical components and mechanical components that are present in the AC, right? Yes or no? This is because of what? Aging of components. Because of, right? So whatever system you take, right? Whether it is a feedback control system or open loop control system or whatever control system you take, any system you take, right? So with the time, its components will degrade, right? That is because every component will have some lifespan, right? So because of the changes in the components, what happens is the output of the system changes. Yes or no? The output of the system is changing. The behavior of the system is changing. Everything is changing, right? So what does this sensitivity give is within this feedback loop, within this particular feedback loop, if there are any changes in G, right? Let us say if there is 1 unit change in G, there is 1 unit change in G. For 1 unit change in G, the overall transfer function changes by how many units? These many units, right? For 1 unit change in G, the overall transfer function changes by these many units. That is what sensitivity is saying directly, right? So just find out dou m by dou G multiplied by G by m for this overall transfer function. Just partially differentiate this G by 1 plus GH with respect to G and calculate this and tell me what answer are you getting. So sensitivity in overall transfer function with respect to G, what is the definition? It is dou m by dou G multiplied by G by m, right? So this is sensitivity. All this we are discussing is for this particular system only. For a general closed loop system, we are discussing this. For a general closed loop system, we are discussing this. For a general negative feedback closed loop system, we are discussing this. Got it or not? Right? So what is the overall transfer function of this? Overall transfer function m is equal to what? M is equal to G by 1 plus GH. Right? You have to partially differentiate m with respect to G. Right? So dou m by dou G is equal to what? Just partially differentiate this. What will you get? Use U by V rule. U dash V minus U V dash. If you differentiate this, you will get H only. U dash V minus U V dash upon V square, right? So this multiplied by what? This multiplied by G divided by M, right? this multiplied by G divided by M means, this is M divided by M means 1 plus GH divided by G, right? So this G and G gets cancelled, this 1 plus GH and square gets cancelled. You are left with what? Sensitivity of overall transfer function with respect to G is equal to 1 divided by 1 plus GH, right? So this is the sensitivity, right? Therefore, if you want this sensitivity in percentage, this is per unit sensitivity, just multiply this per unit sensitivity with respect to 100, with 100, you will get percentage sensitivity. So this is sensitivity of any closed loop transfer function. This is the closed loop transfer function, right? So for this is the sensitivity, that is 1 by 1 plus GH. Is it clear? Is it clear, everyone? Right? So what does this indicate? What does this indicate? So sensitivity of M with respect to G. What does it infer? It straight away infers one simple thing, right? So if there is 1 unit change in G, let us say in G we have 1 unit of change, right? In overall transfer function we will have 1 by 1 plus GH units of change. If we have 1 unit of change in G, we will have 1 by 1 plus GH units of change in overall transfer function. That is what is said here. Is it clear? Right? So let us say if G is equal to some 10. G is equal to 10. Right? So this H is equal to some 0.9. G is equal to 10 and H is equal to 0.9. What is M? M is equal to 10 divided by 1 plus 10 into 0.9, that is 9, that is equal to what? M is equal to 1. Of course, M is equal to 1, right? So what is sensitivity? Sensitivity is sensitivity of overall transfer function with respect to G is 1 by 1 plus GH, 1 by 1 plus 9, 0.9 into 10, that is 1 by 1 plus 9, that is 1 by 10. 1 by 10 means 0.1, right? So what does it say? What does this calculation say? This says that if there is 1 unit change in G, right? G, the forward path transfer function whichever we have, if there is 1 unit change in G, this will change by 0.1%, 0.1 unit, right? So see, if G has changed from 10 to 9, let us say it has changed by 1 unit, right? The overall transfer function will change by how many units? Overall transfer function M will become 0.9. That's it. That is what it is saying, right? For 1 unit change in G, there will be 0.1 units change in M. Yes, that is what our G is saying, right? Is it clear, everyone? Is sensitivity concept clear? So sensitivity of overall transfer function with respect to feed forward path, that is G. Forward path transfer function is this, right? So can you find out sensitivity of overall transfer function? Sensitivity of overall transfer function with respect to H. Can you find it out? Sensitivity of overall transfer function with respect to what? With respect to feedback path transfer function. Can you find it out and tell me? What is the answer? Sensitivity of overall transfer function with respect to feedback path transfer function is, so dou M by dou H multiplied by H upon M multiplied by 100, if you want it in percentage, right? Just calculate this and tell me the answer, right? So it is a partial derivative of overall transfer function with respect to H, right? So derivative of G by 1 plus GH, what will you get? Derivative of G by 1 plus GH, it is minus G by 1 plus GH whole square, right? 1 by X derivative. And derivative of this inner part with respect to H, you will get what? You will get G multiplied by what? Multiplied by H and divided by m, that is 1 plus gh divided by g. So this g and g is cancelled, let us say, right? This and this square gets cancelled. You will get minus gh by 1 plus gh into, right? So minus gh by 1 plus gh into 100. This is the sensitivity of overall transfer function with respect to feedback path transfer function. Feedback path transfer function, right? So for any positive changes in G, right, you can make appropriate positive changes in H so that you could compensate this, right? So you could compensate this. You cannot exactly nullify this, right? You can compensate this to some degree, right? So positive changes जो होते हैं उन्हें counteract कर सकते हैं in negative changes करके, right? We can counteract the positive changes that are happening because of changes in G by making appropriate changes in H, right? So this is the consequence. So mathematically sometimes you might be asked to calculate these things also, right? So take this question now. Negative feedback in a closed loop control system does not. So which option is correct? Negative feedback in a closed loop control system does not. So reduce overall gain. Let us look at option A, right? So using a negative feedback, this is a negative feedback configuration, right? So you are using this negative feedback configuration. So what is the overall transfer function? Overall transfer function is g by 1 plus gh, right? If at all you are not using this negative feedback, you are taking an open loop control system like this, right? There is no feedback if you take some system like this, right? So what is the overall transfer function in this case? Overall transfer function is g only, whereas in this case, what is happening? The gain has reduced by what factor? 1 plus gh factor, right? So gain has reduced by 1 plus gh factor. Gain is reduced. Gain is reduced. So option A is not the answer. Why? So m is equal to g by 1 plus gh. Gain is reduced or not? Gain is reduced, right? But according to the statement, negative feedback in a control system does not reduce what, right? So it has reduced gain. Therefore, option A will not be your correct answer, right? So option B, bandwidth, you don't know yet, right? We will see what is how it will vary bandwidth, right? So option C, improves disturbance rejection, right? So let us say you have some particular signal, you have some particular disturbance that is feeding into this system like this, right? This is your negative feedback system, right? So some particular disturbance is being fed into your system's response, right? So what is the response? Your response of your system is something like this, right? Let us say this is the response, but a disturbance is induced, and because of that disturbance, the response has been disturbed, right? Because of this particular disturbance, response has been disturbed, right? So if it is an open loop system, what happens because of disturbance? This disturbance will continue to appear, right? This disturbance will continue to appear like this, right? Your system's response has been disturbed completely. Whereas in the case of a negative feedback system, what will happen is the negative feedback system will always take feedback and it will counteract for disturbances and changes. It will again bring it to the original position, right? It will again bring it to the original position, which means disturbance rejection is improved, right? So disturbance rejection is improved. What is improved? Disturbance rejection. Disturbance rejection is improved. In which system? In negative feedback system. In negative feedback system, right? Therefore, option C cannot be the correct answer also. See here. See, this is our system's response, system's output with respect to time. Let us say system's output with respect to time, right? So remaining people, did you understand or not? Just acknowledge here. right? This is the output of the system with respect to time, right? If we are introducing some disturbance in our response, right? In an open loop system, in a system which there is no feedback, right? In that particular system, what happens? The disturbance whichever is induced, that will continue to appear at the output. Whereas in a feedback system, in a system like this, what happens to the disturbance? If there is some disturbance, the system will retain its state. The system will come back to its state by taking appropriate feedback, right? The system will come back to its original state by taking appropriate feedback, which means closed loop systems are rejecting disturbances, right? What is happening? Closed loop systems are rejecting disturbances. Yes or no? Right? So closed loop systems are rejecting disturbances means disturbance rejection is improved using closed loop. Right? So option D, let us see, reduce sensitivity to parameter variation. Right? So if there is some system like this which doesn't have any feedback, right? For 1 unit change in G, for 1 unit change in G, what is the change in overall output? Change in overall output is also 1 unit only, because overall transfer function is nothing but G itself, right? If for 1 unit change, if there is 1 unit change in G, then overall transfer function is also G, therefore overall output will also change by 1 unit only, right? Whereas in the case of negative feedback system, what is happening? If 1 unit is changing, right? If 1 unit is changing, what is happening? For 1 unit change, in G, you are getting a change of how much? 1 by 1 plus GH, which means if any parameters are varying, its sensitivity is 100% in the case of a system which does not have feedback, whereas in the case of a system which has feedback, in this case, the unit is 1 by 1 plus GH. The change is 1 by 1 plus GH, which means the change has reduced. Sensitivity to parameter variation, what happened to it? Sensitivity to parameter variations has been reduced. Yes, it is reduced, therefore option D cannot be the correct answer. What is asked? Which does not reduce, right? Sensitivity is reduced, right? Disturbance rejection is improvised, right? Disturbance rejection is improvised, whereas this overall gain is also reduced, right? Therefore, if these three options are not correct, obviously option B would be correct, right? So it does not reduce bandwidth. Actually, what happens to bandwidth is bandwidth increases. Bandwidth increases by 1 plus A beta, right? So we generally don't consider these bandwidth variations in our control systems lecture, right? How bandwidth is varied in a frequency response is generally given by your amplifiers lectures only, right? So amplifiers are nothing but, you have feedback amplifiers, right? Feedback amplifiers, what are they? Negative feedback amplifiers. Negative feedback amplifiers. Negative feedback amplifiers are nothing but, they are designed based on the principles of control systems only. They are designed based on the principles of closed loop control systems only. In amplifiers, you will definitely study the bandwidth of your negative feedback amplifier increases by a factor of 1 plus A beta, right? So if old bandwidth is some BW1, then the new bandwidth BW2 is BW1 multiplied by 1 plus A beta, right? This 1 plus A beta does also have a particular name called desensitivity. Desensitivity. It is called as desensitivity just because 1 plus A beta is called as desensitivity just because this is reciprocal of your sensitivity, right? So is it clear about sensitivity? Right? Sensitivity, what does sensitivity do? It what does closed loop system do? Closed loop feedback, negative feedback do? It will reduce the gain, it will increase the bandwidth, it will improve disturbance rejection, as well as it will reduce the sensitivity to parameter variation. Is it clear, everyone? So let us take this particular question now. As shown in the figure, a negative feedback system has an amplifier of gain with 10% tolerance in the forward path and an attenuator of value 9/100 in the feedback path. The overall system gain is approximately. As shown in the figure, a negative feedback system has an amplifier of gain 100 with 10% tolerance in the forward path and an attenuator of value 9/100 in the feedback path. The overall system gain is approximately. So look at your options also. Options are like this: 10 plus or minus 1%, 10 plus or minus 2%, 10 plus or minus 5%, and 10 plus or minus 10%. Right? So what is the percentage change in G? Percentage change in G is 10%. Right? So for 1% change in G, how much is the change that you are seeing? It is 1 by 1 plus GH into 100. Right? For 10% change in G, how much will be the change? The change will be 1 by 1 plus GH, 10 by 1 plus GH into 100. Yes or no? Right? So what is sensitivity here? Sensitivity of overall transfer function with respect to G is equal to 1 by 1 plus GH multiplied by 100. Right? So from the question it is clear. What is the value of G? What is G and what is H? Tell me. G is 100. Right? G is not 100 plus or minus 10%. G is not 100 plus or minus 10%. G is simply 100. Plus or minus 10% is the variation in G that is being shown using that tolerance notation. Right? So what about H? H is how much? H is 9 by 100. Right? Therefore, for 10% change in G, for 10% change in G, right, for 10% change in G, right, the variation in G is 10%. For 1% change in G, the change in M will be 1 by 1 plus GH, 1 by 1 plus 9, that is equal to 1 by 1 plus 9 is how much? That is equal to 1 by 10 into 100. That is how much? 10% will be the change. For 1% change in G, 10% will be the change in M. Right? For 1% change in G, 10% will be the change in. For 10% change in G, right? Instead of taking this in percentages, let us take in units. Right? How much is the percentage change in G? Percentage change in G is equal to 10%. 10%. So how many units? If it is 10%, 10% means 10 by 100. Right? That is equal to 0.1 unit. Right? 0.1 unit is the change in G. Right? For 0.1 units change in G, what is the overall change in M? Right? So for 1 unit change in G, overall transfer function will change by 1 by 1 plus 9 by 100 multiplied by 100. That is equal to 0.1 unit. For 1 unit change in G, overall change in M will be 0.1 unit. For 0.1 unit change in G, right? Overall change in M will be 0.01 units. Right? For 0.1 unit is equivalent to what? 0.1 unit in G, 0.1 unit change in G is equal to 10% change in G. For 10% change in G, there will be 0.01 means 1 by 100. 1 by 100 units. 1 by 100 units, that is equal to 1%. 1% change in M. 1% change in M. Right? So what is M? Calculate M first of all. M is equal to, calculate M first of all. M is equal to 100 divided by 1 plus 9 by 100 into 100, that is equal to 10. M is 10, right? So percentage change in M is 1%. Therefore, M is equal to 10 plus or minus 10 plus or minus 1%. That is it. So did every one of you get, or is still any doubt is there in this? So I have gone through the best way to explain, because if you calculate it in percentages, you might there is a chance that you might get confused, right? So take the changes in units, so you will come to understand. So for 10% change means for 0.1 unit change in G, what is the change in M? That is what we need to find out, right? So is everything clear? Let us move on to the next problem. The feedback control system with high gain K is shown below, is shown in the figure below, right? A feedback control system with high gain K is shown in the figure below, right? So please write it down. Write this question down. We'll move on to the next slide. Then the closed loop transfer function is, option A, sensitive to perturbations in G of S and H of S. Option B, sensitive to perturbations in G of S but not to perturbations in H of S. Option C, sensitive to perturbations in H of S but not to perturbations in G of S. And option D, insensitive to perturbations in G of S and H of S. Perturbations means variations, deviations, right? Disturbances. There is nothing new in this. This is simply K, G, H. So this is the block. So option A is sensitive to perturbations in G of S and H of S. Option B is sensitive to perturbations in G of S but not H of S. Option C is sensitive to perturbations in H of S but not to variations in G of S, right? Option D is insensitive to variations in G of S and H of S, right? So which one? So majority of you have given option A as right answer, right? Majority of you have given option A as right answer. So sensitivity with respect to G of S and H of S, that is what they are asking. Sensitivity of overall transfer function with respect to G of S. What is the formula for this? 1 by 1 plus GH. Sensitivity of overall transfer function with respect to H is minus GH divided by 1 plus GH. So we'll see whether it is C, B or D, right? So yes, Rintu Ghosh, very good. K is very high. See, in this question, the forward path transfer function is what? K times of G, right? K times of G, right? So this is effectively considered as G now. In the place of G, you have K times of G. That's it, right? So for this system, what is sensitivity? Sensitivity of overall transfer function with respect to G for this particular system, what is it? In the place of G, you have Kg, right? 1 by 1 plus Kgh, right? 1 by 1 plus Kgh. Sensitivity of overall transfer function with respect to H is what here? It is minus Kgh divided by 1 plus Kgh. It is given K is very high. K is very high, right? So do one thing, put limit K approaches infinity. Limit K approaches infinity. Because K is high, K is very, very high, which means K approaches infinity, right? So put k approaches infinity and solve the limits and tell me what are the limits you are getting. So limit for this, how will you calculate the limit for this? Limit k approaches infinity. So this is giving you infinity by infinity form, right? So infinite by infinite form, which means undetermined, right? Indeterminate form, therefore take this k common. In the numerator you have a k common and take k common in the denominator. That is k into 1 by k plus gh simply, right? So you can cancel this k and this k, right? So if you put k is equal to infinity in this, there is no k term in this at all, right? If you put there is k term in this in the denominator, therefore if you put k is equal to infinity in this, it is gh by 0, 1 by infinity is 0 plus gh, you will get 1. This is 1. Whereas what about this? In this there is no k in the numerator, you have to directly put k is equal to infinity. If you put k is equal to infinity, you will get 1 by infinity, that is equal to 0. Therefore sensitivity of parameter variations in G is 0, whereas sensitivity because of parameter variations in H is -1. Yes, Taiba, it is -1. Thank you for reminding. Option C is the correct answer, right? Because sensitivity to parameter variations in G is 0, which means it is not sensitive to parameter variations, whereas sensitivity to parameter variations in H is -1, which means this is sensitive. This is sensitive for parameter variations in -1, right? So this is the answer. Very, very interesting question, very important question also, right? So from sensitivity, this is the best question till date we have in GATE. This was given for 2 marks. Upmanyu, positive and negative sensitivity means nothing. See here. See, how did we get this negative? Because of this derivative we got this negative, that's it. So because of this derivative, while we have calculated this derivative with respect to H, we got this negative, that's it. There is nothing called as positive sensitivity, negative sensitivity, or else neutral sensitivity. There is nothing like that. Is it clear?